All right, this is the inference for 2 samples lab 9, and this is the formula version. So we're going to begin like we always do by putting in the packages that we need. So library mosaic and library GG formula, and clicking the play button. We're gonna load in our data here. So we're gonna need to do a little bit of data cleaning to ensure that this is gonna work properly for the lab. So I need to filter out GSS so that a couple of variables that I'm gonna use later don't have empty strings in them. So I'm just gonna control enter here, and that's gonna filter down my data a little bit. So today we're doing inference for 2 samples, and that means doing inference either for 2 proportions or for 2 means. This is going to be very similar to what we did in lab 7 when we were doing inference for a single proportion or a single mean. Just like that, we're going to be using distributional approximations, a normal distribution for a difference of proportions, and a t-distribution for a difference of means. And we're going to do our main inferential tasks. So we're going to do both confidence intervals and hypothesis tests. So we're going to start with the proportions, the difference of proportions. And one of the things that we need to do is compute the standard error. And the formula is going to be different based on whether we're doing a confidence interval or a hypothesis test. So for a confidence interval, we use P1 and P2 in our standard error formula. But for a hypothesis test, we use p hat, which is the pooled proportion. So here we're using the individual P1 and P2, and here we're doing the overall proportion. As always, we can use R like a calculator. I did that in lab 7, so you could go back and look at that if you wanted to do it that way. But we can also use formulas and functions in R. So we're going to try making a confidence interval for a difference of 2 proportions. And what I'm interested in is the proportion of people who said marijuana should be made legal. And I want to compare based on whether that person is self-employed or if they work for somebody else. So if you click on the data set and you scroll over, you can see there's this variable self-emp or works for somebody else, whether they work for someone else or they're self-employed. And then there's some questions about their opinions on things. So one of them is, should marijuana be made legal? And that has 2 options, not legal or legal. So we're gonna try to start by finding our observed statistic. And I would encourage you to try and do this on your own before you go further in the video. All right, I'm gonna do it. So I'm going to do a tally, and I'm going to tally up should underscore marijuana underscore be underscore made legal tilde, and then self emp or underscore works underscore for underscore somebody, comma data is equal to GSS. And if I control enter, now I have the 2-way table with the numbers. That's not exactly what I want. I really want the format equal proportion. And so this is going to show me that of the self-employed people, it looks like 69% of them think marijuana should be legal, 31% of them think no, and the people who work for someone else, 64.6 and 35.3. So I did the variables the correct way around here. So this is the variable that I'm most interested in, and this is the one that I want it broken down by. But if you had flipped the variables, you would have gotten different proportions. So it's important to think about whether your proportions add up to 1 in the correct way. So maybe I'll do a subtraction here. So the 0.69 minus 0.64, that would be a difference of 0.05. Our point estimate for the difference is 0.05. That is 5% more people who are self-employed believe marijuana should be made legal compared to those who are employed by someone else. And of course, that's just our point estimate. So we see that there's this difference, this 5 percentage points, but we want to know, is it statistically significant? So one way that we could do that is with a confidence interval. Let's try and do a 90% confidence interval. So if I just control enter on this prop.test, I'm going to get a 95% confidence interval. So if I wanted to make a 90% interval, I'd put a comma and then hit tab, and I would change the conf.level. So I could hit tab again and it would fill it out 0.90. And now it's going to give me a 90% confidence interval. So I could interpret that interval. I could say I am 90% confident that I'm 90% confident that the percentage of people who are self-employed who believe marijuana should be made legal is between 0.03, so that's 3%, 3 percentage points less, and 11.5 percentage points more than the percent of non-self-employed people who believe that. So basically, this interval contains 0, and that means that we are not very confident. People could either be 3 percentage points less to 11.5 percentage points more. So we're really not sure about who is more in support of that. We could also do a hypothesis test, and the first thing we'd want to do is write out our hypotheses. So we can use LaTeX to do that, and I can say H0 is P1 equal to P2, and HA is P1 / NEQ P2 not equal. And I could also I could move things around. So P1 minus P2 is equal to 0, and P1 minus P2 is / NEQ 0. So that has the null value of 0, which explains why we're not like subtracting something off when we're doing inference here. And in order to do that test, we would just need to add a few more arguments to our function. So we've still got our prop.test, we've got our variable that we're interested in, we've got our variable that we want to break it down by, data equal GSS, comma. Then we need to put our alternative in here, which could be, it says 2.sided, greater or less. And so I want it to be 2.sided. And then I might also want to specify something about success. And let's say success is legal. So now this again makes me a confidence interval. It's a 95% confidence interval, but then what we're really interested in is the p-value here because we're doing the test. So our p-value is 0.3489, which is very large. So we fail to reject our null hypothesis. We do not have evidence to suggest that the true proportion of people who support the legalization of marijuana is different between self-employed people and those who work for someone else. So that goes along with what we found with our confidence interval. We were really not sure about the proportion difference, and now we're finding this p-value that's really large. So that's consistent.